Okay, so this is chapter 8. It's called Solutions. So this is a pretty short chapter itself, but it has a lot of information in it when it comes to it. It's very little, little different than we talked about before in the other chapters as well. So in this chapter, we're going to talk about the strength of the liquid. So how strong, the drug actually is when it comes to it. So you kind of think of coffee, right? If you just drink of coffee, it's pretty strong. But, if you put sugar, you sweeten it, but it dilutes it. So it makes it much easier to smoother to drink when it comes to it. And that's what we're going to be doing here is, given, this drug itself, is there a way we can, break it down to a simple level? That way, it's easier for a patient to drink. It is not, it's going to kill you, right, when it comes to it. So when it comes to this chapter, there are three very special definitions we're talking about. So the first one is called a solute. The solute is a solid or liquid to be dissolved or diluted. So basically, you could think of this as the drug itself. Okay. Some solutes are powder drugs, chemical salts, liquids. So in our case, it's going to be powder and liquid itself for the drugs. Okay. The solute, or other word for its dilute, is a liquid that dissolves a solute, solvent, or dilute to liquid. Now in our case, it's going to be two commonly occurring ones. The two common ones is normal saline and sterile water. Okay, so essentially, we're going to put the drug into sterile water, normal saline, to dilute it, meaning make it less stronger, so it's easier to drink or go through the body. Okay. Now, next definition is called a solution. So the solution is the liquid resulting from the combination of the solute and solvent. So you can think of the solution, both the solvent and solute put together, right, in one whole complete solution. Okay. Now, when it comes to the solutions of label, the strength of the solution is always, if you want to think of it, solute plus solvent, right? That's the whole thing. So you're adding these two together to get the entire solution. So for instance, if I add 5 milliliters here and I have 20 milliliters of solute, combining total, I have 25 total solution. Does that make sense, right? It's the combined total of the entire liquid put together. Okay, so they're just like this and this is all together is the entire solution. Okay. So we're going to break this down into two different types of categories. The first one's going to call liquids, and the other one's a little harder, is called dries. Well, what I want to do now is slowly get into this concept of, strength of a drug. So how are solutions labeled? Okay, so the strength is considered is the amount of drug, so the solute, always divided by the volume of the solution. So it is the drug divided by the entire volume, right? So meaning volume, the sum of both the solute and solvent put together. Okay? And that's always going to be the case. So here are some examples. KCl 2 mcg per milliliter, or herpene, we'll talk about units in a little bit, 500 units per milliliter. Okay, so again, volume is always in liters or liquid, so it's always milliliters or liters on the bottom. Okay, so here's a little example illustrating how this works out. So let's suppose we have sulfur 5 milligrams per milliliter, means there for every 5 milliliters of this ferment, there is exactly in 1 milliliter of the solution. Okay, so it's 5 to 1 ratio. We'll talk about the ratios in a bit, but that's what this means is for every we have 5 milligrams for every 1 milliliter of solution. So drug per 1 milliliter of solution. Okay. So that's what this represents. So here's another example. If we have 17 milligrams per milliliter, the second one is stronger. So the second one is stronger and is more because it has more force in the second one and when it comes to it. So when we talk about this portion is we're also going to talk about which is actually stronger. How do we know that based off the information? And a lot of times it's not going to give you a straight out portion, right? For this case, you can see this is stronger because this has more drug into it than this one. But later on, we'll see what does it actually mean to be stronger or less than that portion. Okay, so we'll talk about that in a little bit, so don't stress too much about it. But the main focus I want to talk about now is the types of ways we can express this. Okay, so express this drug or the strength of this drug. So there's 3 different types we're going to talk about. It's a ratio, percent, and a fraction. So the fraction we've already talked about before. The percent looks like this, like 0.9% NaCl. Okay, the ratio part is this one is a 2, is a 1, 2 dots to 200. Okay, and now obviously the fraction as well, right, at 1/2. Okay, now like I said earlier, right, the strength is always solute over solution or drug over solution. Okay, so what I want to do now is just quickly do an example to show you guys how would you actually, write this type of strength of graphs. So it says how to understand the solution. So if the solution is a ratio of a drug is 1 to 3, 1/3, or 33, these all mean the exact same thing, right? This is 1/3, 1/3, and 1/3 respectively in each category. So you can think of this. So if we have the entire solution, so the entire beaker is broken into 3 parts, right? Because we have total of 3 parts. Okay? What this is saying is, because I have 1 part drug. This whole thing is solution. And I have 2 parts that are solvent. Okay? So that's how you break it up. So remember, the last number will always give you the total. The first number just gives you just the drug. Okay? So when it comes to this, I can ask you different questions. I can say, well, how much is it in the drug? You can say there's 1 unit for every 3. How much in the solvent? There's 2, because 1, 2, 3 gives you the grand total of the solution, right? Okay. So let's try another portion. Let's suppose we have another little example of 2 to 5. Okay. So what this is saying, for every 5 units, right, we have total of 5 units of solution, there are 2 units of drug. So if we go by doing this pattern of boxes, this means I have 5 total boxes, and 2 of them are drug or solute. So this is the drug, this is the solvent, and this is totally solution. Okay. And that's how you express a ratio, fraction. It all means the same thing, right? 33% means, this is 3 of them. 1/3 in the ratio makes it easier to see, when it comes to the percentages. We rarely can do something like that, but, hopefully you guys get the gist of how to actually express it as itself. Okay. So now we have that. We're going to go into the liquids. So what these liquids represent. Now, believe it or not, these are actually the hardest ones to deal with when it comes to strength liquids. The reason why is because it's actually unitless. That's a key thing, because it's liquid over liquid, which means they're gone, right? Milliliters or milliliters is no units, right? So here's an example of it. So given the ratio of 1 to 40 milliliters, there is 1 milliliter for a drug, liquid drug, and there's 39 milliliters of solvent, which gives you a grand total of 40, right? So we already talked about this, so I just gave you guys a little example when it comes to it. Now, when it comes to liquid drugs, they usually will tell you this is liquid, volume, or anything like that. That way it gives you a hint. You're talking about liquid drugs, not dry drugs. We'll talk about a little bit. Okay? So example 1 says here, suppose 40 milliliters of iodine solution contains 10 milliliters of, so I'll give you the hints, right? Solute is pure iodine. Express the strength of this drug as a ratio, fraction, and percent. So why don't you guys try that, right? So try question 1 and 2 based off that, because question 2 is the same thing. So I'll give you a quick pause, and then try these out, express it in all 3 phases, right? Express it as a ratio, fraction, and also a percentage. And over here, it just asks you to convert it into a percent. Okay, so go for it. 3, 2, 1. Okay, so hopefully you guys try this, right? So it says, suppose 40 milliliters of iodine solution. So remember, that tells you, right? That's your 40 milliliters of solution. And 10 milliliters is your solute. That's your drug. So we want to express this in 3 ways, right? The easiest way is probably the fraction format, is 10 over 40. The other one is 10 to 40. And you can divide this if you want, right? You could say 1/4 if you like. It's perfectly fine. And then for the percentage, you just divide, right? So 10 goes into 40. 0.25 times 100 is 25%. So the percent is 25%. Okay. Right, so now let's try question 2. So question 2 says, if 250 milliliters of solution contains 15 milliliters of hydrogen chloric acid. So again, easy what it is. This is a drug. And remember, it says solution. So this is our solution there. Find the strength of the hydrochloric acid in the solution. So find the strength. Well, let's go back over here. Strength is drug over solution, right? So it's going to be drug, so 15 milliliters over 250 milliliters. Okay. So therefore, you just divide them, and we're done. So it should give you, I believe, 0.6. 0.06. 0.06 is your strength. And again, it's unionless because milliliters actually cancel. That's the reason why it's a little tricky when it comes to liquids. Okay. So now if we keep going, drugs are actually much easier to deal with when it comes to it, believe it or not. Okay. The reason why dry drugs are pretty easy to deal with little camera. There we go. Is because dry drugs are always in one category. So it's not liquid or liquid. When it comes to this, it's always going to be considered in grams. That's the best part. So given the ratio, let's say 1 to 20, that means there's always 1 gram, not milligrams, kilograms, it's grams. So it's always in grams. 1 gram of solute in every 20 milliliters of solution. Okay. So again, the key thing, I cannot stress this enough. Solutes, when it comes to dry drugs, is always in grams. So for example, if you have 5% potassium percussinate, express it as a fraction and ratio. Well, the fraction is, right, it's a percent, so it's 5 over 100. And now we put the units. So there are 5 grams for every 100 milliliters. Right, that's the fraction format. The ratio is 5 to 100. Okay. Again, right, the key thing is, in case you forget, right, a percentage is always out of 100, right, never out of anything else. So just quick little scenario when it comes to it. Okay. And again, you can divide them and make it easier, but you know, you can leave them just like that, or you can say, you know, 1 out of 20. That's easier to deal with, but same thing. Okay. So go ahead and try question 4 now. Okay. So I'll give you guys a quick question. 3, 2, 1, pause. Okay, so hopefully you guys tried it. It's the same as above, but just give you a practice when it comes to, you know, when it comes to dry solutions. So there are 75 grams of drug dissolved in 140 milliliters of solution. What is the strength of this solution expressed in all 3 forms? Now notice it didn't tell you what is the solute and what is the solution, right? So at this point you're going to have to know, because notice grams. So you know already without a doubt you're doing dry solution because it gives you in grams, not liquid. Therefore, you know, by default, this must be solution, even though, you know, they tell you, but sometimes they may not tell you itself. Okay, so what is the strength in all 3 forms? Well, 75 grams over 140 milliliters. It's 75 to 140, and the percentage form is 52.9. Or you could we'll just round it to 53%. Okay. And then from there, we can just do the same questions we did in last chapters, right? Basically from that format. So for example, 5 says, if there is 0.2% of hydrochloride, express it in milligrams per milliliter. Well, no, remember, this doesn't tell you if it's liquid or volume, right? This instance right here. However, notice what's asked you to do. Milligrams per milliliter. So therefore, you know by default, this must be in dry solution, right, when it comes to it. Okay. Right, so I think I'll stop there. There's the next video coming up in a little bit.